Okay, so question 3. Construct a 7th order Taylor polynomial. In other words, we need some polynomial that's going to go to x to the 7th, and the infinitely long Taylor series for sine x at x is equal to 0. Okay, so here's what we know. Our function is f of x is equal to sine x. So we need to create a polynomial that's going to behave, that we're going to have, start off with it being, let's call it tangent centered at x is equal to 0. So I'm going to need f of 0. I'm going to need f prime. I'm going to need f double prime all the way down to the 7th derivative. So the first derivative of sine is cosine. The second derivative, you know, is negative sine of x. The third derivative, I'm just going to do that notation, is negative cosine of x. The fourth derivative is sine of x. The fifth derivative is cosine of x. The sixth derivative is negative sine of x. And the seventh derivative is negative cosine of x. So now let's plug 0 into this. So f of 0 is 0. F prime of 0 is 1. F double prime of 0 is 0. F triple prime of 0 is negative 1. F fourth derivative at 0 is 0. The fifth derivative at 0 is positive 1. The sixth derivative at 0 is 0. The seventh derivative at 0 is negative 1. So let's create this polynomial. Our 7th order polynomial is going to start with 0, but then we're going to have plus 1 over 1 factorial x to the first, 0x squared. We're going to have minus 1 over 3 factorial x to the third. We're going to have 0 x to the fourth. We're going to have 1 over 5 factorial x to the fifth, 0x to the sixth, and we're going to have negative 1 over 7 factorial x to the seventh. So in more compact form, I'm going to call this p sub 7 just to indicate it goes to the 7th power. We're going to have x minus 1 over 3 factorial x to the third plus 1 over 5 factorial x to the fifth minus 1 over 7 factorial x to the seventh. Interesting. Okay, so there's my 7th order Taylor polynomial. I could add infinitely many terms, so I could keep on going, and I'm noticing the pattern. So for my Taylor series, which is just going to be infinitely long, I'm not going to write the whole thing out, but I definitely can write this in summation notation. So let's see, I'm going to start with k is equal to 0. And we're going to go to infinity. And let's see, our first term has a positive coefficient. So I'm going to call this negative 1 to the kth power would work. This is where k is 1, so it's negative k is 2 is positive, k is 3 is negative. And then the pattern is going to be, notice we have consecutive odd numbers. Again, this is where k is equal to 1. This is where k is equal to 2. So I'm guessing that this is going to be x to the power of 2k plus 1 over 2k plus 1 factorial. And you might need to play around with that a little bit. Okay, so that's my Taylor series. Let's just take a look at this and see what it looks like. So I'm going to, let me just change back to radian mode, and I'm going to go from my window, I'm going to say negative pi to pi. I know I don't have to have very big y values. I'm going to, for y sub 1, just plug in sine of x. For y sub 2, I'm going to plug in as many terms as I can. So we're going to have x minus, and I'm going to type this in as x to the third, but then divided by 3 factorial. And factorial, you know, is under probability. Okay, and then I'm going to have plus, and I'll have x to the fifth, but I'm going to divide that by 5 factorial. And I'm going to have minus x to the seventh divided by 7 factorial. And I'm going to stop there and just see how this looks. So when I go to graph this, okay, so there's my sine graph. And there's my polynomial graph. Let's make this a little bit bigger. Negative 6 pi to 6 pi. Can't possibly be that good a fit. There's my sine. And there's my polynomial. Goodness gracious, so it comes in. So it looks like it cozies up to it for a little bit, but then goes off in its own direction. So I'm going to add a few more terms and see what happens. Okay, so for this one, for y sub 2, we've done minus x to the 7th. Let's add x to the 9th and divide it by 9 factorial. And why don't we do minus x to the 11th, but then divide it by 11 factorial. And see what that looks like. Sine. And there's the polynomial coming in, swooping right along, and it looks like it's the region over which it's converging has definitely widened. So that's kind of amazing.